Okay, so once again, good evening, everyone. So for today, we're going to have a discussions about pointers, no? So we're going to start with the understanding of the void pointers, no? So a void pointer, also known as generic pointer, is a pointer that has no specific data type, no, associated with it. It can hold the address of any data type. So the void pointer is declared using the keyword void, no, and is used to represent a memory allocation. So the void pointer is commonly used in C and C++ programming languages and Java programming. It allows you to allocate memory without specifying the data type, which makes it more flexible than other pointer types. However, since the void pointer has no data type, you cannot reference it directly. So to access the data pointed to by void pointer, you must first cast it to the appropriate data type. Let's say, for example, if you have a void pointer that points to an integer, you must first cast it to an integer pointer before differentiating it. Let's say, for example, of how you can use a void pointer in C language programming. So we start, let's say, void, tapos asterisk PTR semicolon, no? Int num is equal to 10 semicolon. That is a variable, no? And as you can see, we declare int as we declare void, then we declare integer as our data types and num as our variable. So PTR is equal to ampersand num semicolon. It means to say that we assign the address of num to PTR. Then int space asterisk int underscore PTR is equal to open parenthesis int asterisk close parenthesis PTR. That is to cast the PTR to an integer pointer. And we use printf open parenthesis double quotation %d as because integer use %d, no, as our data types. So for data types ng integer is %d double quotation comma asterisk int underscore PTR close parenthesis semicolon. This will be the dereference integer and int underscore PTR to reprint the value of num. In this example, no, we declare a void pointer called PTR and initialize it to point to the address of an integer variable num. We then cast PTR to an integer pointer int underscore PTR using the int asterisk, no, syntax. So finally, we dereference, no, int underscore PTR to print the value of num. Because again, bear in mind that it is important to note that using void pointers can be dangerous if not used carefully. Since you can assign any data type to a void pointer, you must be careful when casting it to ensure that you are accessing the correct data type. Additionally, dereferencing an incorrectly cast void pointer can lead to unexpected behavior or even crashes. So I just, of course, always show you a video presentation wherein you could able to appreciate the use of void, no? Because just saying the void, it's too hard for us to understand, but if we could able to see the demonstration, how we'll be able to use, maybe it's too easy for us to understand it well, okay?
From this presentation onwards, we will try to understand some special. It is important for us to understand some special pointers. So here is one such special pointer called void pointer. In this presentation, we will try to understand what are void pointers. Okay, so let's get started. What is a void pointer? Void pointer is a pointer which has no associated data type with it. Now, this is an interesting kind of pointer, right? Which has no associated data type. It can point to any data of any data type. Here you can see that void pointer has no associated data type. The speciality of this pointer is that it can point to any data of any data type and can be typecasted to any type as well. Let's discuss one example. Here in this case, let's say we have a main function, and within this main function, we have a variable n which has been initialized with value 10. After that, we have a void pointer. Here you can see this pointer has no associated data type, although it is containing the address of variable n, but I have declared this pointer as a void pointer. This pointer has no associated data type, so it can point to any type of data, as this is what I have written over here. That is why I'm initializing this with the address of this variable. After that, we are using this printf function, and here in this printf function, you can clearly see that the pointer has been typecasted first and then the dereferences happen. Here you can see that this pointer has been typecasted first. Now what is the meaning of typecasting? It means that you are changing the type of the pointer. Here this pointer is a void pointer. We need to typecast it before using it. That is why typecasting is important. As it is written over here that it can be typecasted to any type, so here we are typecasting it to an integer pointer. Now this pointer becomes an integer pointer and now we can dereference it without any problem. After dereferencing, the output will be 10, right? Because it contains the address of this variable. When we dereference this pointer, the value 10 will get printed on the screen. So this is what void pointer is, but let me tell you that we cannot dereference a void pointer directly. It is important for us to typecast our pointer before dereferencing it. Here typecasting is very important. So if you are using it directly, then obviously you will get an error message. So you need to be very careful about this. Now you might be having a question why we are even using this pointer. Eventually we need to typecast it to some other pointer. Why can't we simply use an integer pointer? Why we are even bothering about this type of pointer? Why there is a need of typecasting? We have to typecast it, then use it. Why so many things we have to do when we can simply use an integer pointer? Let's discuss the use of void pointer. Malloc and calloc function returns a void pointer. Let me tell you, these are the built-in functions which are used to allocate memory dynamically. We will discuss these two functions later. Right now you should understand that malloc and calloc function returns a void pointer. Due to this reason, they can allocate a memory for any type of data. As I have told you, these are built-in functions that are used to allocate memory. Let me tell you that because these functions return void pointer, they can allocate memory for any type of data. Without knowing the type of data, they can allocate memory. This is the reason why we are using void pointers. Now you can understand why void pointers are so important. Malloc and calloc functions are built-in functions that are used to allocate memory for any type of data. They can do this because they are returning the pointer which are pointing to some memory location without knowing the type of data which will get stored within them. So it is interesting, isn't that so? Here is the syntax of malloc function. You can see over here that malloc function is returning a void pointer, right? I'm just giving you the syntax. Here you don't need to understand this right now. Right now there is no requirement. Malloc and calloc are used to allocate memory at runtime. I have already told you, right? Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so that this will be an example actually of using the void pointers. Now, I just want to discuss the next one, which will be the understanding the null pointers. Now, so if we've heard the word void pointers, we also always heard the word null pointers. In programming, a null pointer is a pointer that does not point to valid memory address. No, so it is represented by the value 0 and C in C++, and by the keyword null PTR in C++ and later. No? So a null pointer can be useful when you need to indicate that a pointer does not point to anything. So for example, if you declare a pointer but haven't yet assigned it a valid memory address, its value will be null. So you can also assign a null pointer to a pointer variable to explicitly indicate that it does not point to anything. However, it's important to note that the referencing null pointer, so attempting to access the memory it pointers to, it is undefined behavior and it can lead to crashes or other unexpected behavior. It's common mistake for beginner programmers to forget to initialize their pointer. So let's say initialize is equal to 0 and so on. So which can lead to null pointer error. So let's say, for example, so int asterisk PTR is equal to null PTR. This will be to declare a null pointer. Then if open pares PTR is equal to null PTR, close pares open, then std : C out, yung ano natin sa C++, no, yung dalawang less than, double quotation, PTR is a null pointer, then dalawa ulit na less than, std, dalawang colon, and one semicolon, and end. In this example, no, we declare a null pointer PTR of type int asterisk and initialize it to null PTR. So we then check if PTR is equal to null PTR using the equal operator, which returns true if the two operands are equal. in C language programming, so a while ago, that's C++ example. In C++ programming, we use int asterisk space PTR is equal to null, naka-uppercase yung null, semicolon. This will be the declare a null pointer. Then if open parenthesis PTR is equal to null, uppercase yung null, close parenthesis begin, print f, open parenthesis double quotation PTR is a null pointer, \n double quotation, close parenthesis semicolon, then n. In this example, in C language programming, we declare a null pointer PTR of type int asterisk and initialize it to null. So we then check if PTR is equal to null using the equal operator and print a message to the console it is. So it's a good practice to always initialize your pointer to null or a valid memory address to avoid null pointers error. So again, I just want to show you a demonstration of a program.
Here in this presentation, we will try to understand null pointers in details. Let me tell you, it is a special type of pointer. After considering void pointers, it is important for us to understand what are null pointers. So let's get started. What is a null pointer? A null pointer is a pointer that does not point to any memory location. Let me tell you, it is a special type of pointer that does not point to any memory location. Or in other words, you can say that it represents an invalid memory location. When a null value is assigned to a pointer, then the pointer is considered as null pointer. It is a special type of pointer. Null is itself a pointer. When we initialize a pointer with null, then that pointer also becomes a null pointer. For example, here in this case, we have initialized this pointer with null. So this is a null pointer. Okay. Now here are some uses of null pointer. The first use is, it is used to initialize a pointer when that pointer isn't assigned any valid memory address yet. For example, here in this case, we are using this null pointer to initialize a pointer. It is better to initialize a pointer with null when it is not containing any valid memory address. So it is a good practice to initialize a pointer with null. Apart from this, it is useful for handling errors when using malloc function. We have already discussed a little bit about malloc function in the previous lecture. Malloc function is a built-in function which is used to allocate memory dynamically. Malloc function returns a pointer, right? Sometimes malloc returns null when memory is not available. In that case, we can use that null for handling errors. For example, here in this case, this PTR contains the address of some memory location which has been returned by this malloc function. Right now, you don't need to understand this, okay? The one thing you should understand is that PTR contains the address of some memory location. If it doesn't contain the address of some memory location, then it contains null. Okay, that is also returned by malloc. Here we are checking if PTR is equal to null, then in that case memory could not be allocated. Otherwise, memory allocated successfully. As simple as that. If PTR is null, then memory could not be allocated, else memory allocated successfully. Now let's discuss some of the facts about null pointer. The value of null is 0. Let me tell you, the value of null is 0. We can either use null or 0, but this 0 is written in the context of pointers and is not equivalent to the integer 0. You should not confuse it with the integer 0, let me tell you. It is a special kind of value which is representing a null pointer, by the way. We can either write null or 0. Both are same in context of pointers. Okay. For example, here in this case, PTR has been initialized with null. Here you can see I am trying to print the value associated with this null, basically a decimal value. So output will be 0 in this case. Because null and 0 both are same. You can also initialize this pointer with 0. But let me tell you, it is not a good practice. Okay. Instead of initializing a pointer with 0, you should initialize this with null. To avoid any confusions further, it is better to initialize a pointer with null. Now here comes the second fact. Size of the null pointer depends upon the platform and is similar to the size of the normal pointers. Here in this case, when I run this code on my computer, I got this as an output, that is 8 bytes, right? So size of null is 8 bytes in my computer. It might be possible that it is 4 bytes in your computer. That depends on your platform. So these are the facts about null pointers, okay? Now let's discuss some best practices. Here, it is good practice to initialize a pointer as null. It is a very good practice, let me tell you. A pointer should be initialized to null if it is not pointing to some valid memory address. So it is a good practice if we initialize a pointer as null to avoid any errors, of course. Also, it is a good practice to perform null check before dereferencing any pointer to avoid surprises. Before dereferencing a pointer, we should perform a null check. Okay friends, this is it for now. Thank you for watching this presentation.
Okay. So, right after that, the next will be understanding the dangling pointer. No? So, a dangling pointer is a pointer that points to a memory location that has been freed and deleted. So, dangling pointers can arise when you deallocate memory that was previously allocated with malloc. So, or new. So, but fails to update all the pointers that were pointing to that memory. When a pointer becomes a dangling pointer, it can cause undefined behavior when you attempt to dereference it. This can result in program crashes, memory corruptions, or other unexpected behavior. So, an example of how dangling pointer can occur in C++, let's say for example, int space underscore asterisk ptr is equal to new int, that is to allocate memory for an integer asterisk ptr is equal to 10. No? Then backslash of course assign a value to the integer delete ptr and for pre-memory, and ptr is now a dangling pointer. In this example, we declare a pointer ptr of type int asterisk and allocate memory for an integer using the new operator. So we then assign a value to the integer and free the memory using the delete operator. However, we fail to update the value of PTR, which still points to the now freed memory allocation. And this makes PTR a dangling pointer, and any attempt to dereference it will result in undefined behavior. So to avoid dangling pointers, you should always ensure that all pointers pointing to a memory location are updated when that memory is deallocated. One common technique is to set the pointer to null or a valid memory location after freeing the memory to prevent it from becoming a dangling pointer. So another example for how to prevent dangling pointer by setting the pointer to null after freeing the memory. So int, no, of course, asterisk ptr is equal to new int. That is allocate memory for the integer asterisk ptr. Okay, then asterisk ptr is equal to 10. That is assign a value to integer. Then delete ptr, that is to free the memory. Then ptr is equal to null ptr, that is to set ptr to null to prevent a dangling pointer. In this example, no, we allocate memory for an integer assigned to a value to it and free the memory using the delete operator. So when then set the value of PTR to null PTR, which ensures that it does not point to a freed memory allocation and prevents it from becoming a dangling pointer. It is also good practice, no, to avoid using raw pointers whenever possible, and instead use smart pointers or other memory management techniques, which can help prevent dangling pointers and other memory issues. Okay, I'll just want to play again a video presentation.
In this presentation, we will try to understand what are dangling points. So let's get started. What is a dangling pointer, by the way? A dangling pointer is a pointer which points to some non-existing memory location. It is a special type of pointer which points to some non-existing memory location. For example, here in this case, PTR contains the address of the first byte of the memory allocated by malloc. Let me tell you that malloc is the function which allocates memory dynamically. I have already gave a glimpse about this in the previous lectures. Malloc is the function which allocates memory dynamically. After allocating the memory, malloc simply returns the address of the first byte of the memory. And that address I am trying to store here in this PTR pointer, right? So PTR contains the address of the first byte of that memory location. After performing some operations, now what I am trying to do here is, I am trying to free the memory. That is, I am trying to release the memory, or I can say I am trying to deallocate the memory. So malloc has allocated some memory. After performing some operations, I am just deallocating the memory using this free function. It is a special type of function which we will discuss later. Right now you should understand that this function is used to deallocate the memory allocated by this function malloc. Okay. So here in this case, you can clearly see that we are deallocating the memory after using the memory. But you should understand this point also, that the pointer PTR is still pointing to the deallocated memory, isn't that so? Let us assume that the address of the first byte of the memory is 1000. PTR still contains that address even after deallocating the memory, because we haven't reinitialized the pointer, as simple as that. After releasing the memory, PTR is still containing that address. That is why PTR is called a dangling pointer. Why is that so? Please see the definition once again. A dangling pointer is a pointer which points to some non-existing memory location. When you free the memory, when you release the memory, after that pointer becomes dangling because it is pointing to the non-existing memory location. After deallocating the memory, memory doesn't exist, but pointer is still pointing to that memory. This is called dangling pointer. Okay. What is the solution for this problem? Solution is simple, just reinitialize the pointer. Now here in this case, PTR has been initialized with null. Obviously this is the simplest possible step. Just initialize the pointer with null. Now this is legal, right? So PTR is no more dangling. Dangling pointers cause problems later in your code. If you free the memory which has been previously allocated, then maybe you try to dereference the pointer and try to access the contents from that location, but that location simply doesn't exist. So to avoid such problems, obviously, we need to reinitialize the pointer once again after freeing the memory. This is very important step. Now, let's consider example number 2. Here in this case, you can clearly see I have a function fun and obviously I have a main function. Within this main function, we have a PTR pointer which contains null. Initially, obviously, this is the best practice. I have already talked about this. PTR is the pointer. Right now, it is not pointing to any object, so it is better to initialize it with null. After that, what we are doing here is we are trying to call this function fun and we will store the address returned by this function within this PTR. Okay? You can clearly see within this fun function, we have a variable num which has been initialized with value 10 and we are trying to return the address of this num variable. You can understand that num is a variable which is local to this function. Isn't that so? When this function finishes its execution, then obviously this variable get vanished. This is the meaning of a local variable, right? This variable is local to this function. As long as this function exists, this variable exists. But after the execution of this function, the variable will simply doesn't exist. So it is just like deallocating the memory, and that too automatically. So when we try to return the address of this variable, obviously we are trying to return the address of non-existing memory. Here we are trying to store that address within this PTR pointer. So obviously this PTR becomes a dangling pointer. And here we are trying to dereference it. So it will cause segmentation fault. Segmentation fault simply means that you are trying to read or write into an illegal memory location. Here you can clearly see that num is local to this function. After function finishes its execution, num variable will get vanished, which means that it will no more exist. Obviously this means that memory has been deallocated and we are trying to return the address of the deallocated memory, and this simply means that we are trying to return the address of a non-existing memory, right? That is why segmentation fault occurs. So obviously it is important to avoid such practices. Try not to return the address of a local variable from a function. Okay friends, this is it for now. Thank you for watching this presentation.
Okay. So next will be the understanding the wild pointers, no? A wild pointer is a pointer that points to an arbitrary memory location, which may or may not be valid or accessible. So, wild pointers can arise when you declare a pointer variable but fail to initialize it or assign it a valid memory address. When a pointer becomes a wild pointer, attempting to dereference, no, it can cause undefined behavior, including program crashes, memory corruptions, or other unexpected behavior. Wild pointers can be particularly dangerous because they are often difficult to diagnose and can lead to hard to find bugs in your code. So let's say, for example, for a wild pointer using C++, no, int space and asterisk PTR semicolon. That is declare a pointer but don't initialize it. Asterisk PTR is equal to 10 semicolon. That is attempt to assign a value to the pointer. So PTR is now a wild pointer. No? In this example, we declare a pointer PTR of type int, but do not initialize it or assign it as a valid variable address or valid memory address rather. Excuse. When we attempt to assign a value to the pointer, which result is undefined behavior because PTR points to an arbitrary memory location. So to avoid wild pointers, you should always initialize your pointers to valid memory address or to null PTR. And or null, and you actually null PTR for C++ and null in C language programming. So you should also ensure that your pointer variables are updated whenever the memory they point to is deallocated or changes location. Another example, of course, for on how to avoid a wild pointer by initializing the pointer to null and assigning it a valid memory address is int as it is space asterisk PTR is equal to null PTR semicolon. That is initialize the pointer to null. Then int space num is equal to 10 semicolon. That is declare an integer variable. Then PTR is equal to an ampersand num semicolon. That is assign the pointer to the address of num. So therefore PTR now points to a valid memory location. So in this example, we initialize the pointer PTR to null PTR, which ensures that it does not point to an arbitrary memory location. So we then declare an integer variable num and assign the address of num to the pointer using the ampersand operator, and this ensures that PTR points to a valid memory location and avoids a wild pointer error. In addition to initializing your pointers and updating them as needed, you should also use good coding practices such as defensive programming and proper error handling to help prevent wild pointers errors and other memory related issues in your code. Okay, so this will be the
In this presentation, we will try to understand what are wild pointers. So let's get started. Wild pointers are also known as uninitialized pointers. Let me tell you, they are the pointers which are uninitialized. Okay. So these pointers usually point to some arbitrary memory location and may cause a program to crash or misbehave. Obviously, they may point to some memory location which we even don't know, right? They definitely do not contain the address of some valid memory location, right? So it may cause a program to crash or misbehave. For example, here in this case, this pointer has not been initialized yet. And here we are trying to dereference this pointer. This means that we are trying to access the location pointed by this pointer. And we are also storing this value within that location. Obviously, this may cause the program to crash. It may even cause segmentation fault. We are trying to write into the memory, which is an illegal memory. Basically, this pointer may contain the address of some illegal memory location. So that is why this pointer is a wild pointer. It wildly behaves and may cause a program to crash or misbehave. So this is a wild pointer without any doubt. Now, how to avoid wild pointers? What are the best practices to avoid wild pointers? The best practice is to initialize them with the address of a known variable. Here in this case, you can clearly see that pointer has been initialized with the address of this variable var. So it is clear that this will no more be a wild pointer. It contains the address of a variable. There is no problem with this. Second is that we should explicitly allocate the memory and put the values in the allocated memory. Here in this example, you can clearly see that we are allocating the memory using malloc. This is also a legal step. Here we are initializing this pointer with the address of the first byte of the memory allocated by this function. And obviously we can access that location and put some values within them. This is fine. Either you should assign the address of some variable or some object, or explicitly allocate the memory and put the values in the allocated memory. These two steps are fine to avoid wild pointers. Okay friends, this is it for now. Thank you for watching this presentation.
Okay. Most commonly in programming, we just simply use the pointer, no? Let's say, for example, the ampersand and asterisk, no? Because again, pointer are a fundamental concept in computer programming that allow programs to work with memory and manipulate data in more efficient and flexible ways. So again, some key points to keep in mind, no? A pointer is a variable that stores the memory address of another variable. Pointers are often used to pass large data structure of arrays to functions without making a copy of the data. Then, okay, so a while ago, no, I'm just sharing on how or some keys, no, points to keep in mind. Okay, so I'm done already with number 1. No, pointer is a variable that stores the memory address of another variable. Number 2, pointers are often used to pass large data structures or arrays to functions without making a copy of the data. Number 3, pointers can be used to allocate and deallocate memory dynamically at runtime. Number 4, pointers can be used to create data structures like linked lists, trees, and graphs. Number 5, pointers can be used to interact with hardware devices and system resources. Number 6, pointer arithmetic can be used to navigate through arrays and manipulate data in memory. Number 7, pointers must be carefully managed to avoid errors like null pointer dereferences, memory leaks, and buffer overflows. And lastly, pointers are a powerful tool, but they can also make programs more complex and harder to debug. Okay, so I think that's it for about